Okay, for 4.4 and 4.5, we're going to learn new ways to prove that triangles are congruent. So we're going to first just review from last week. So 4.4 triangle congruence. By the end of today, we will know how to prove triangles are congruent by these two new reasons. So last week, the only way that we knew triangles were congruent is to show that all 6 pairs of corresponding parts were congruent. So when I say corresponding parts, what I mean is you had to show that all 3 sides were congruent, and you had to show all 3 angles were congruent. So that's a long process. If you have to show that those are congruent, that means in each proof you would have to have 6 statements. You have to have 3 statements showing the sides are congruent, and then 3 more showing that the angles are congruent. But there's quicker ways that we can prove that. So that's what we're going to learn about today. The first one is called side, side, side. Okay, so we have SSS. That is the abbreviation. And then you guys just drew 2 triangles. So you already have these labeled. So one way you can tell if the sides are congruent is if they have the same length. And for ABC and DEF, we were given the lengths of all the sides. So AB is 4 and DF is 4. AC was 7 and ED was 7. BC is 6 and EF is 6. Okay, so as you can see, these are not always drawn to scale. What I want you to do is I want you to finish the congruent statement. So congruent statement, that's a vocab word that we learned last week. I'm going to give you triangle ABC, and then I want you to write what triangle it's congruent to. So remember that your order matters. Okay, so you're going to use your capital letters and make sure you put like your triangle symbol. Okay, so you have to write the other triangle. Okay, so Andrew, will you tell me what first letter you used here?
D.
Okay, can you tell me why?
Because it started on A and then it goes down to D.
Okay.
And the length of AB is 4, so D going down F, that's 4.
Perfect. Yeah, that's great. Okay, so from A to B, it was 4 units, and I started with AB. From D to F, it was 4 units. So if this starts with AB, this has to start with DF. Perfect. Okay, and then your last one, it would be DF and then E. Okay, it cannot be any other order besides DFE. Okay, it has to go in that order. Okay, the next one, this is an example of what you could be given. So we have, this is our picture. It's given that KM bisects LN. So Ryan, what does it mean when something bisects?
It's like a line that goes through segments, maybe.
Okay, and what's special about the way that it goes through it?
They're equal.
What is equal?
The 2 segments.
Okay, so wherever it splits it, right, the 2 segments that are formed from that are going to be congruent. Danny and Kaden, knock it off. So let's think about what this means. Okay, if KM bisects LN, then we can say that 2 segments are congruent. Ava B, what do you think? What 2 segments are congruent if KM bisects LN? Good. Okay, so it would be LM and NM are congruent. Okay, so we would say LM is congruent to NM by the definition of a bisector. Okay, and then, sorry, you should also be given this. Okay, so you'd also be given that KL is congruent to NK. And then that would be marked in our diagram. All right, now if we're going to show that all three sides are congruent, sorry, we'll mark these like this. Okay, if we want to show all three sides are congruent, there's only one more side. And this is going to be really important. You're going to notice this a lot. If you look at both of these triangles, can you see that KM is shared by both of them? It's in both of the triangles. Whenever there's a shared side, then you can say that KM is congruent to itself by what property? No? So, yeah, okay, good, reflexive. If you have something that's congruent to itself, that is the reflexive property. Now, what we would be trying to do here is prove those two triangles are congruent. So we would say that triangle KLM is congruent to, and again, when I name this, I need to be careful of how I name this. So from K to L, that's going to match up with K to N. And so this will be KNM, and this would be by side, side, side. This would also be by side, side, side. Okay, that's your side, side, side congruence theorem. Now, before we talk about the next theorem, we have to make sure we understand what is meant by included angle. So, an included angle is an angle that's formed by two adjacent sides of a polygon. Okay, and then just remember, if it's adjacent, it means that it's next to. So I'm going to give you a triangle, and then we are going to name our adjacent parts together. Okay, so here's your triangle. We're going to call it ABC. And we are going to look at angle B first. Okay, so angle B is the included angle between sides. So write this down with me. Angle B is the included angle between sides, and the two sides it's between is AB and BC. Okay, so if I look at the position of angle B, I can see that the two sides that are right next to it are AB and BC. I want you guys to tell me what angle A is the included angle for. So angle A is the included angle between sides blank and blank. And you're going to fill in the blanks. And then you're going to do the same thing for angle C. Okay, so angle C is the included angle between sides blank and blank. Okay, and I'm going to give you a minute to fill those in. And then we're going to check and see how we did. too about what you wrote for these. Tyler, what'd you get for the first one? Angle A is included between what two sides?
BA and AC.
Yes. And I just put AB. Okay, so you said AB, and what was the other one? So A is in between side AB and
I didn't say that.
I thought you said AB. Oh,
No.
you said BA. Yeah. And I said yeah, AB. Same thing. BA AB.
Okay.
Yep.
AC.
Okay, so AB and then AC. Good. Yep, and if you guys said BA and CA, that's the same thing. Okay, so what do we notice already about these two and their relationship to the included angle? Anybody tell me how they'd explain it to somebody? Or a
The
pattern that
included
you
angle
noticed?
is the one it's going to be the first one on the second one.
Okay, so if your included angle's A, what has to be in both of these? A. If the included angle's B, what do I have to have in both of these? B, right? So the angle is always going to be a part of the sides. So see how BC does not even touch angle A? That's how I know it will not be part of the included angle. Okay, good. And then Grace, what'd you get for the last one? Good, BC and AC. And I just wrote them as AC and BC. Same thing. Yep. So you could have AC and BC, you could have CA, CB, or a combination of those. Okay, good. So now that we know what an included angle is, that's going to help us for side angle side. Okay, so I want you to either highlight or underline the condition for side angle side congruence. Okay, so those are a few keywords that I want you to zone in on. Okay, so I want you guys to highlight or underline what is the condition. And really, the condition is going to be what part of your statement? The hypothesis, right? Okay, so Alex, what is side angle side congruence? What has to happen?
One triangle is two sides and the included angle, or another triangle and the triangle above it.
Okay, so you just tell me, what do you have to have? What has to be congruent to what?
The included triangle is congruent to another triangle.
That, so not the included triangle, but the included
Angle.
angle. Okay, so it's the included angle, but aside from the included angle, what else do you have to have? So think about what your hypothesis is, right? The hypothesis is always after, what's your hypothesis always after? Remember hypothesis, conclusion from your statements? No, you don't remember? Nobody around you remembers?
No, I do.
Oh, okay.
If.
Yeah,
I
it's
didn't
what.
know you were talking about the word.
I thought we were talking about
like
science.
before it.
Yeah, no, yeah. So after if, it says two sides and the included angle, right? So it's two sides and the included angle. That's what you need, right? Two sides and the included angle of one triangle have to be congruent to two sides and the included angle of another triangle. Okay, so it's two sides and the included angle. That's the main thing. Two sides and the included angle. then you know your triangles are congruent to each other. So let's do a couple more examples here. Your first one, part A, we'll call. We're going to draw two triangles. And we have ABC, and we have DEF. And then these are going to have some special marks on them. So this is all given to you. Alright, so if you have two triangles with these exact markings, again, I'm going to have you finish your congruent statement. So triangle ABC is congruent to, and go ahead and write in what it is. Alright, so Bobby, how did you start this one? Okay, and tell me how you knew it started with E, that's right.
Because it's in the same place the A was.
Okay, and really it's the markings, right? So if you can see A has that one curved line and E has that one curved line, you know that A is congruent to E. Okay, now from here, it's either going to go from E to D or E to F. Robert, how can you decide which way to go?
Well, A went to B, and B had like the one line.
Yep.
So then E to F has the one line.
Good. So he said from A to B, that has your one line here, right? So you have to go from E to F because you know AB is congruent to EF based on that one line. So this should be EFD, okay? And then that can't be written any other way. And again, we would say that these are congruent by side, angle, side. So if you look at the picture, I always think of it like this: side, angle, side. Side, angle, side. You just won't have any part that it skips. SAS, SAS. All right, let's do one that looks a little bit different. So sometimes you're going to have triangles that overlap. So we're going to start with a straight line. And we're going to go up. And then go ahead and go up again. And again, remember that sometimes your stuff is not going to be drawn to scale, and that's okay. All right, and then we are going to label this as A, B, and really I'm just going to stop at every point. So this will be C, this will be D, this will be E, this will be F, this will be G. Okay, and we are going to be given a few things. So we are given that AG is 5 and GF is 5. We are given that BC is 2, CD is 3, DE is 2. And we are also given that these two sides are congruent and these two angles are congruent. And then we'll actually learn in another lesson that whenever you have an isosceles triangle, the angles across from them are congruent too. This one gives it to you because we haven't talked about that yet. Okay, so what we want to do is prove that these two triangles, ABD and FCE, are congruent to each other. So whenever you have two triangles that crisscross, I think it's helpful to redraw them separately. So I would draw ABD here. Okay, and then for this one it would be CFE. And then I want you to go ahead and label the parts that you know. Okay, so label the parts that you know. Okay, well, first of all, angle D is marked with this symbol, and angle C is marked with this symbol, so that's one of the first things I'd mark off. Now, I know that AG is 5. Do I know what this length is? No, but I do know it's the same as this length. So if I don't know what it is, I can just call it what? I just call it X, right? So let's just call this part X. And then because these are the same, this would be X. So then, Danny, how could I write the length of AD? If I know this part is 5 and this part is X. X plus 5, okay? Make sure that you do write it as plus, not times, because you would add these two lengths together. So this length is 5 plus X, or X plus 5. This length is 5 plus X, or X plus 5. All right, and then Cam, can I figure out the length of BD?
Yeah.
Yeah, what's that?
5, because add the 2 and the 3.
Yeah, so if you add the 2 and the 3 together, you'll get 5. Same thing with CE. If you add 3 and 2, you'll get 5. Okay, I don't know what AB is. I don't know what FE is here, but that's all right. So now I can look at these and I can say, oh, well, these lengths are the same, 5 and 5, so those are congruent. 5 plus X is congruent to 5 plus X, which means these are congruent by SAS, side angle side. So ABD, and then I want you to finish the statement, and that's by side angle side. Okay, so start with AB. So AB is this side, and Ava M, what would I start with here? So if here I start with AB, what would I put for this one? What else? Good. Yeah, good. FEC. Okay, so AB and FE are the same, and then you're left with your C. Okay, so it has to be FEC. All right. Let's go to the next, where we will continue this. So in the directions, it says show that the triangles are congruent for the given value of the variable. So you have to show that these two triangles are congruent when y equals 4. And then you're given these pictures. So I'm going to give you about a minute to find what your lengths are when you know that y equals 4. And then after a minute, I'll just call on you guys to help me. one of the first things that you found?
I did U, T,
Okay, yeah. So UT, what'd you get?
7.
Good. Okay, so you plugged in 4, and then you found that UT was 7. Perfect. Okay, so UT is going to be 7. And then let's think about what that means. So if UT is 7, then Lance, I know that UT is congruent to what?
WX.
Yep. Good. Okay, so if UT is going to be 7, then UT is congruent to WX. All right, and then, Kaden, what's the other part that you found?
ST. Yeah, ST.
Good, okay, and what is ST going to be?
V2.
Let's check it. So when you plug in 4, you get 2 times 4, which is...
Oh, wow. 11.
Yep, so 2 times 4 is 8. 8 plus 3 will be 11. Okay. All right, so then, Kaden, tell me what ST is going to be congruent to.
What?
That's all right. Just take a second. Shh. I know. Use your paper, right?
Found it. VW.
Okay. And then I'm just going to say, yeah, I would say VW. Good. Okay, so ST is congruent to VW. And then, Alex D, what's the last thing?
The last thing is the angle T.
Okay, yep. What'd you get for angle T?
I have 92.
Good. And what does that mean? If we know angle T is 92 degrees, what else do we know?
That I'm smart.
How about in terms of the triangle?
It's not a right triangle.
But if you look at your 2 triangles, right, that we're comparing, angle T is going to be the same as what? You can do it.
Angle W.
Okay, so then we're going to say that they're congruent. So remember, our whole goal is to show that we have some type of congruence, either SAS or SSS. Now, because those are the only 2 that we have right now, things are pretty nice because obviously if you have an angle, you're going to have side angle side, okay, if you have the 2 sides in the included angle. So here, this is your side angle side. Side angle side. Okay, so then what we would say is triangle STU is congruent to angle VWX by side angle side. All right, and then everybody's favorite part is our proof. Woo! So,
Is this supposed to say 4 4s?
no, this one's supposed to say 4 5. So with your proofs, we're getting lots of practice here. So now we're going to have some where I'll tell you the number of steps, and then you are going to fill out both the statements and the reasons. For this one, I'm going to tell you that your 2 given statements, you're going to split up into 2. Okay, so I want you to go ahead and fill in all of the boxes you possibly can, which at the very least you should have 5 filled in. Okay, so you should automatically have 5 boxes filled in, just from what you're given and what you have to prove. Okay, so the first one is N is parallel to M. EG, which should have the segment on it, is congruent to HF. And then your triangle EFG is congruent to triangle HFG. Okay, and I walked around and it seemed like you guys had a good handle on that start. But now the work begins. So, remember I told you it's going to be really important to mark things off on your diagram. Okay, so when they tell me that N is parallel to M, not only do I want to mark this off on my diagram, but now I'm going to start thinking. When I'm told that something is parallel, what's something that can come after that? If two lines are parallel, what can be formed? Yeah.
The lines that are parallel. Oh, I know.
So that's already in our statement. Yeah, Kaden?
Linear pairs.
No. Yep.
Like the lines in between the two of them that create the angles that equal 180.
Congruent.
Not exactly what I'm looking for. So if two lines are parallel, what do they make?
180.
No.
Lines. 90.
No. They make,
They make parallel.
they don't intersect.
That's correct. But what special things are formed when you have two parallel lines?
Linear pairs.
No. Definitely, okay, definitely not a linear pair, because if you just have two parallel lines, we aren't even talking about the transversal, right? If you have two parallel lines that are cut by a transversal, what do we have?
Straight lines.
Or math is equal.
We have congruent angles. What type of angles?
Straight.
No. I'm very
Vertical.
disappointed that we don't remember from last week that all of your special angles are going to be formed. Corresponding, alternate interior, alternate exterior. So that is what we're going to put for our third step. They already tell you that EG is congruent to EF. When you're looking at your triangles that have to be proved congruent, it might be a good idea to just outline them so you know what two triangles you're trying to prove. That can help you pick up on some angles. So a common type of angle that we see is the alternate interior. So alternate interior angles, if you have parallel lines, are formed. So that would be like angle EGF and angle HFG. And that would be the alternate interior angles theorem. Now the next one is what I told you about earlier today. Can you see how these share a side? If they share a side, we can say GF is congruent to, now in this one, they're kind of like backwards. You can say GF is congruent to FG, or if you said GF was congruent to itself, that would be fine for this. But that would be the reflexive property. But you can say either one. Okay, so you could, or if you said FG, that would be fine. But anytime they share a side, that has to happen.
So would it be SAS?
Yes, so it will be side angle side.
Yay. Oh, what?
All right, and then I'll put your homework up here on the video. I'll also have you guys write this down tomorrow.
Wait, what number is on page 240?
Oh, sorry, right there.
All of it.
Okay, so that is your homework.
I was gonna say, Tyler, you had to say it.
Okay, so we are going to go over this tomorrow in my 5th period, but my 3rd period already did this. So to prove your triangles are congruent, these are the only valid reasons we have. So before it was definition of congruent angles. Now we've learned side, 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 and side angle side. You have side, 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 all angles are congruent. Or sorry, all sides are congruent. And if you have side angle side, you have two sides, and the included angle are congruent. Okay, so that means if you're doing a proof, If you had two triangles are congruent, these are the only reasons we know right now that you can use.